Welcome back everyone. Now we are going to learn about the preparation of the ammonia and the amines. Don't mind about my ammonia thing. We are going to study about the amines. So preparation of the amines. So basically there is one most important thing in preparation of the amine, which is the reduction, the word reduction. So how we are going to reduce anything, either by eliminating the oxygen from it or by adding the hydrogen to it. So what if we do both the things? So let's see in the reduction of nitro compound. So let's take an example. Here is our benzene, and in this one we take NO2, nitrogen dioxide, and let's react it in the presence of hydrogen. And remember, wherever we take the hydrogen, we need to consider nickel, palladium, or platinum. In this case, we are considering Pd, as most of the books do, but you can use nickel or platinum either. And we are going to take ethanol, the alcohol, and we are going to get our product here. So this is the same thing as the reactant side. Okay, let me make a beautiful benzene for us. So this is our benzene again, but this time something is different going to happen. So try to notice. Now we have NH2 plus O2. So this is the entire story. As we can see, the O2 get removed because of the hydrogen, and hydrogen attacked on this. Hydrogen is added here and oxygen gas is separate. So this is the gas form and also a stable one. So it will get evaporate and we'll get our 1 degree ammonia, or we can also call it as um, benzene ammonia. So here is a question. Why we are using ethanol? What is its role? Palladium, as I told you, wherever we use the hydrogen to control the rods, we need palladium, platinum or nickel. But why there is ethanol? Ethanol is a base, right? So why we are using base when oxygen is already there, which is itself is the base. If you notice, ethanol's formula is C2H5OH. So we are adding more oxygen to this oxygen. So the reason for this is quite logical and very simple. The reason is, if you add or have the presence of ethanol in your reactant, so it will going to disturb the O2's environment, and when it gets disturbed because of the more electron density, it will lose its bond, and when O2 loses, S2 comes in, like we seen in this case. S2 comes in and O2 get loosened up. So this is the entire logic for this one. I hope you have understood it very well, and we're going to see one more reaction after this. So let's see the other reaction. So the other reaction is something like this. Again, we are taking the, I'm going to make the big diagrams so that you can see things quite easily. And instead of making three bonds again and again, I'm using the circle so that you can understand that the bonds do not stay in its own place. It keeps on changing, so we can make it in a cyclic form. Okay, so here we are going to use Sn, and this time we are going to use the acid, which is HCl. And the more interesting is, we can also use iron here and HCl. So before we are using the base, now we are going to use acid. So let's see what is going to happen in this case. So let's make our benzene first. So our benzene is ready, and we are going to get NH2. That's interesting because technically we only have one H. So definitely it's not the reaction we are looking for. We need to use 2HCl. So two hydrogens get added in this place and we have again O2. But what about Cl? Where this Cl is supposed to go? Where this Cl will go? So this Cl is going to 2 times also. So it will going to form either Cl2, which is also a gas. So we have two gases here, chlorine gas and oxygen gas, and we get our 1 degree ammonia. This time by using the acidic nature. So we need only a small amount of the acid to initiate the reaction because FeCl2 forms, and in its formation the things become easy. So this is easy to handle reaction, and as we have quite enough iron and knowledge about the iron, the things becomes quite simple. So the logic is very simple. Whatever we call ammonia, we just require one important thing, that is we need nitrogen and hydrogen, or maybe in place of hydrogen we will consider R, which is itself is carbon and hydrogen only. So if there's anything else, we are supposed to remove this. Like in previous two reactions, we seen that we had oxygen here. So we remove the oxygen, and that itself is the meaning of reduction. So we are reducing and adding the hydrogen in its place. So that's it for this preparation. We are going to see ammonolysis and one more level on the reaction part. So stick with me to learn more deep and clear.